For successful tuning of a Tesla coil, we need to make sure the resonant frequency of the primary matches that of the secondary. We find the point of resonance by putting a variable high frequency signal into the coil using a signal generator. Then, as you vary the frequency, you look for a voltage peak across the coil with the oscilloscope. This is the way things are set up. The oscilloscope probe hangs about 3 foot away from the secondary. Simply just holding it won't work, as it needs to be hung so it doesn't move or swing around. And just the one connection from the signal generator goes to the base of the secondary coil. Apart from the probe, normally you would want to avoid having any other objects within the distance you would normally expect streams to reach, as it can affect the result. Also, some people remove the primary whilst doing the secondary, as that can also affect things. I find it to be negligible though, altering by 1.5 kHz at the most, whereas a streamer can alter things by as much as 15 kHz, as we will see later in part 2. So I'm starting at 130 kHz and increasing the frequency while watching the scope, looking for a peak. Now we have something here, let's just enlarge that. Now if we increase the frequency, it drops away, so we know we have resonance at 148 kHz. Close by, you can see how it alters the self-capacitance of the coil and therefore its resonance. The reason for showing you this is so you appreciate that the streamers will also have the same effect, so it's a good idea to simulate this when tuning by hanging a piece of wire from the toroid. This should be the same length as an expected streamer. Look at the oscilloscope and you'll see the result of me approaching the coil and then leaving the simulated streamer attached to the toroid. Remove it and the coil is back in resonance. Here is the same thing again as the wire is added. That's the piece of wire now connected. And now we're tuning it again. Measuring it, you can see that the frequency has now dropped. This new frequency of 139 kHz is what we'll set the primary to. To measure the primary, the setup is a little different and we need to use this arrangement instead. The spark gap is shorted out and both the oscilloscope and the generator are connected across the primary coil. You will also need a resistance in one of the generator input leads as well. On my generator 10,000 ohms was ideal. Without this resistance the oscilloscope will be reading the generator's output rather than the coil's resonant voltage peak. Some people measure the primary on its own, in which case you'll need to remove the toroid and the secondary coil. Altering the primary frequency is done by moving the tap position. Moving it outwards will give a lower resonant frequency and vice versa. The actual method of measuring the primary is exactly the same as the secondary, which we saw earlier, so there's no real need to repeat it. You just simply find the frequency that gives the maximum voltage across the coil, then make adjustments to the position of the tap so that the primary matches the secondary frequency that we got using a simulated streamer. This is best done slowly, about 1/4 of a turn at a time. This is my own 4.7 inch 1 kVA coil running on two 10k NSTs. The cap bank is 22 nanofarad with a 193 thou suction spark gap. The two hoses connect to a heavy duty vacuum cleaner with the air going in via the front inlet. This all means the gap is fairly quiet in operation but still only gets hand warm after 5 minutes of running.